tonight?
Good, how are you?
Good. So I got your message that you'd done the first 4 of these.
Yeah.
Well, that's good, because if you can do the first 4, you can probably do all the rest.
Well, I did these in class with assisted help from my teacher, so I honestly don't know what I'm doing.
All right. Let's start with difference of squares. Factor that for me. What is a squared minus b squared?
I don't know.
A minus
Oh, wouldn't it just be a minus b and a minus b?
Times a plus b.
Right.
Okay, in other words, if you had 4 squared minus 3 squared, that would be 4 minus 3 times 4 plus 3. Okay? And we can see that that's what it is. It's 16 minus 9, so it should be 7, and that's what I get over here, is 7.
Right.
All right. So, it's important to remember difference of squares this way. I get a lot of students that remember it this way. And I'm always tempted to say something to them about it. Now, those two things are the same. But there's an advantage of memorizing it this way. And the advantage is that when you get to difference and sum of cubes, the first term is always the same sign. And it's linear, just like difference of perfect squares. And then the next term is a squared, opposite sign of whatever this sign is, and it's ab, it's not 2ab, like we're used to. That's what difference of squares is. Excuse me, difference of cubes. This is difference of squares. This is difference of cubes, and we have the sum of cubes. Why do we not have the sum of squares? Because you can't factor the sum of squares. You can factor the sum of cubes. And it looks very similar to the difference of cubes. And always start your first linear term with the same sign. That way it's really easy to memorize. This part, opposite sign of whatever this sign is, this is opposite.
Okay.
Now look at all 3 of those and notice the similarities and the differences. You need to memorize all 3 of these.
Okay.
And there's no other way about it. I mean, I've given you all the tricks I know.
All right.
The tricks I know is that the linear term is the same sign. Notice that it's negative, 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 positive, positive. And the next term is the opposite sign. A plus b, and here we have a plus sign in front of the middle term, and here we have a minus sign in front of the middle term. So that's it. That's the only way I know how to memorize them.
Okay.
Okay? I'm going to take away this page.
Okay.
To do these problems.
All right. I wrote it down anyways.
All of these problems are sum and difference of cubes. So we need to know those formulas. And notice that we're always going, if we recognize this as the difference of perfect cubes, because that is 4 cubed, and this is what cubed? 343.
You just take the square root of it?
Not the square root of it, the cube root of it.
Oh.
Raise it. No, it's going to be a whole number.
7.
Okay.
So when A equals 7 and B
In other words,
equals
let's look at this. This is A cubed minus B cubed. Okay. We know that that's what?
7.
No, what's the formula for it? We're going to plug in after, but you need to know the general formula.
It would be A minus B.
Right. The first term is always linear, no matter whether it's difference of squares, difference of cubes, sum of cubes. The first term is linear. By that I mean that everything is to the 1 power. Okay. The second term always starts like that. What's in the next sign?
Minus AB.
It's always opposite this sign right here. Always.
Right.
All
Sorry.
three.
I was looking at the wrong one.
Okay. And it's AB, and then the last term is always positive if it's a quadratic. So, in our problem here, what is A?
A would be 7.
No, not quite. 7x.
7x.
You see why? Because we need the cube root of 343x cubed. Well, that's 7x cubed.
Right.
And then we need the cube root of 64, which is 4. So B must be 4.
Okay.
Okay? And this step over here on the left is a critical step. I think you need to make it.
Okay.
And now that tells us everything. In other words, if I'm taking A cubed minus B cubed, which I can see that I am, then the answer is going to be what?
7 minus 4.
7x
7x.
minus 4. And then what's the rest of it?
7x squared plus.
Hold on. What is 7x squared? In other words, we need A squared here. A is 7x, so square the whole thing and I'll write it in.
49x
X squared. What is A times B?
Negative 28x.
Where are we getting the negative from? This says positive. A is positive, B is positive. There's no negative sign in here.
Sorry, I was saying the wrong thing. That'd be 28.
28x. And then what is B squared?
16.
And there's your answer. Now, almost never, and I say that facetiously, but it's really true, I've never seen where this quadratic, notice that that is a quadratic, I've never seen where it factors. It just doesn't. For some reason, whenever you have the difference of cubes or the sum of cubes, the resultant quadratic, it never factors down. So don't spend any time trying to do it, because you could waste a lot of time trying to factor that over there on the right.
Right.
All right. So that's the way to do one. Now, let's do another one.
Number 6.
What is this?
Difference of, no, it's, what's it called? Sum of cubes?
Well, there's a minus sign there.
Oh, difference of cubes?
Well, is 4x to the 8th a perfect cube?
Oh, no.
It's really should almost put the word perfect in front of it, because that helps you understand it. It's the difference of perfect squares, or the difference of perfect cubes, or the sum of perfect cubes. Well, this is not a perfect cube. Nor is, well, that is a perfect cube. That is 4 cubed.
Difference of cubes?
But we can't use difference of perfect cubes. If this is not the difference of perfect, in other words, if this is not a perfect cube, we can't use difference of perfect cubes.
Okay.
But I can see that this is a perfect square, and so is this. 64 is 8 squared. 4x to the 8th is
perfect squares.
In other words, that is that. In other words, here's what we really have, is the difference of squares. And there's always multiple ways to do this. I notice you have a note up here saying factor out a 4, and that's okay. You could actually do that, and you'd be left with x to the 8th minus 16. You'd still have the difference of perfect squares. So even if you factor out a 4 as your first step, which is probably the correct first step, nothing wrong with that at all. It doesn't change the answer at all. But it's worth noting that in the original form, we still have the difference of perfect squares. It's trying to figure out whether we have perfect squares or perfect cubes.
Okay.
Okay. Now, the difference of perfect squares factors into what? What's A?
A is 2x to the 4th.
What's B?
Hold on. B is 8 squared.
It's 8.
Okay.
In other words, this is a squared minus b squared. And then this is what over here?
That is 2x to the 4th.
Plus 8.
Plus 8.
In other words, a squared minus b squared is a minus b times a plus b.
Right.
All right. Now,
And then is that the answer?
well, not really, because notice that I can now take a greatest common factor out of this, which is 2 times x to the 4th minus 4, and I can take a greatest common factor out of that. So now, if I really want to be, it's this. Okay, now, is that simplified?
Yes.
That looks like difference of perfect squares to me, and that looks like difference of perfect squares to me.
Okay.
So let's take it down further. Hold on one moment. Yeah, I got the sign wrong here. That should be a plus.
Right.
Okay? However, we still have one that is difference of perfect squares. Notice that this is the sum of perfect squares, but that doesn't do any good. You can't factor that any further. So it's only the difference of perfect squares that you can factor further. So what does x to the 4th minus 4 factor into? That is difference of perfect squares.
Okay, I don't know.
X squared minus 2 times x squared plus 2. And look at that. Notice why that is true. In other words, that is a squared minus b squared. Only a is x squared, and b is 2.
Okay.
Okay? Now, can we factor any further? We got the sum of perfect squares over there. We can't do anything with that. We got the sum of perfect squares there. Can't do anything with that. We got the difference of squares, but not the difference of perfect squares. So we really can't do anything with that. In other words, I mean, you can, but I don't think they want you to. In other words,
Okay.
this is the correct answer.
Okay.
In actuality, it really doesn't have to be perfect squares. This x squared minus 2 actually factors into this.
Yeah, I think we're learning that next class.
Okay. We don't
I
need
think,
to go
yeah,
that
that's what she
far.
said.
If we're dealing with perfect squares or perfect cubes, this is fine. All right, let's look at 7. Now, all right, good thought. Let's take a 2x out. So what's
Okay.
left?
That would be what's it called?
Well,
Sorry, I'm trying to think.
exactly what is left.
It's 8x squared.
8x to the third.
Oh,
Remember
right.
that whenever you factor a greatest common factor out, when you multiply it back together, it has to equal that term.
Right.
And only this would do that. If I would have written down that, well, that doesn't multiply back together to give you that. So
Right.
that's always a check that you should make.
Okay.
And what goes over here?
-1.
Okay. Now, what is that called?
That is called difference of cubes.
Yeah, difference of perfect cubes. Don't forget the word perfect, because all of these problems that you're doing require them to be perfect cubes. Okay, so what is the formula for difference of perfect cubes, and how does it relate to this one? What is a minus b?
2x minus 8x to the third.
Almost. Let's add a step here. Once we see that we're looking at difference of perfect cubes, tell me what A is, and tell me what B is.
A is 2x.
And what's B?
8.
It's 1.
Oh,
Cube
1.
root of, it's the cube root of 1, which is 1.
Right.
Okay? Now, that's all you need to do the rest of it. In other words, if you remember the formula for the rest of it, it's A minus B times A squared plus AB plus B squared. So what's A minus B?
2x minus 1.
What's A squared plus AB plus B squared?
That'd be 4x squared plus A times B, 2x plus 1.
Good. That's your final answer.
Okay.
And you still have to maintain that 2x that we factored out.
Right, so you put that
But
on
this is the trick for you right here. Always do that step. List what A is and list what B is. And then if you have them memorized, you can't go wrong. I mean, that's the nuts.
Right.
All right. X to the fourth minus 625. There's no greatest common factor. Factoring out a 1 doesn't do any good. So, this is either difference of perfect squares or difference of perfect cubes. What is it? It's got to be one or the other, given the material.
Difference of perfect squares.
Okay, what is A and what is B?
A is x squared.
What is B? What's the square root of 625? That's what you always do to figure it out, is take the square root of that.
Okay, which would be 25.
Okay, so what is this thing equal to then?
That would be x squared minus 5 plus 5.
No, minus B.
Plus 25.
We listed B over here.
Right.
Minus 25. What's the rest of it? This is difference of perfect squares, so the rest of it's always really easy. It's the conjugate of that. What's the conjugate of that?
X squared plus 25.
Yeah, we're doing the easy one, difference of perfect squares. We're not doing the hard one, which is difference of perfect cubes. Okay, so difference of perfect squares is always A minus B times A plus B.
Okay.
Okay? This step right here, I can see that if you make that step, you don't make a mistake.
Right.
If you don't make that step, then you're liable to make a mistake. So always try to make that step. All right, 7x to the 6th minus 63. Well, because that's a 7, this is not a difference of perfect squares or difference of perfect cubes, because there's no perfect square for 7 or cube for 7. So it must be, there must be an initial step of factoring out a greatest common factor. And hopefully we'll be left with difference of perfect squares or cubes. So you got a note, factor out the 7, that's good. Now what is this going to be?
That is going to be I don't know.
It's either difference of squares or difference of cubes. What is it?
Difference of cubes.
Well, that would mean we would need the cube root of 9.
Right.
Notice the cube root of 9 is not a whole number. But the square root of 9 is.
Right.
With x to the 6th, we could do either one. In other words, we could do difference of cubes or squares with that. But with this number over here, we can only apply difference of squares.
Okay.
So what's A?
A is 7. No, x to the 3rd.
What's B?
That would be 9.
Square root of 9.
3.
Okay, so now we have 7 A minus B times A plus B. So what's the rest of it?
X third minus 3 would be x to the
A minus B times A plus B. Always.
right. That'd be x to the 3rd squared.
No.
No.
In other words, if this was A minus B, what is A plus B?
Oh, plus 3.
There you go. That's all there is to it when you're dealing with difference of squares. Like I said, difference of squares is the easy one. Difference of cubes is the tough one. Difference of squares is always A minus B times A plus B. It's as simple as that. Once you get the first part, the next part's automatic.
Right.
All right.
So did I complete number 10? Is that right? I don't think so. I didn't finish it.
Well, let's see. That was number 9. I'm not sure we even completed that. I guess we did. In other words, number 9, we still have x cubed minus 3. That's not the difference of perfect cubes. And this is not the sum of perfect cubes, which means I guess we get to leave it like that.
Okay.
Okay?
And then
let's look at 10. And you've realized that the greatest common factor is 2x. And the beauty of factoring out a 2x is what's left behind is what? What is that called? It's got a plus sign in there, so it can only be one thing. We're memorizing 3 things. We're memorizing difference of squares, difference of cubes, and sum of cubes. So what does this have to be?
Sum of cubes.
Right. What's A and what's B?
A is
cube root of that.
Okay, that would be 1.
Always going to be a whole number. Know that. They're not going to give you any problem here that doesn't result in whole numbers.
Okay.
So this has got to be a small number. It's either 3, 4, 5, or 6. One of those.
It's 5.
5, exactly. So what's the cube root? What is A fully? Not 5. It's 5 what?
X.
What's B? Again, it's going to be a small whole number.
Right. It'd be 8. No, 16.
Now hold on. We need a number that's multiplied by itself 3 times. Has to equal 64. Take some of your small numbers and multiply them together 3 times.
Yeah. It'd be 4.
Okay. So, we're dealing with the sum of cubes. So we have to use that formula. So, what is the first part?
That would be 5x. 5x plus
Same
4.
sign. In other words, it's always the same sign for the first term. Whether you're dealing with difference of squares, difference of cubes, or sum of cubes, the sign on the linear term is always the same.
Right.
So it's always plus 4.
Plus 4.
And then it's always opposite on the middle term of the quadratic.
Right.
So what's the quadratic expression?
5x minus 4.
No, it's a squared.
Oh, oops. Okay, that would be 25x squared.
Minus?
Minus,
Are you going to be able to have a cheat sheet on your test?
yeah, and
You
it's
are?
minus 20x. Yeah.
Oh, okay. Well, that
Yeah.
changes everything. You don't have to memorize it if you're going to do that. But you do have to be able to translate it. In other words, from your cheat sheet to an answer. It's the last term.
Plus 16.
Okay. And like I said, don't spend any time trying to factor that. I've never seen it factor, so I don't think it's possible to factor it whenever you've used sum of cubes.
Okay.
That
so
is
that's
by
the goal.
definition a non-factorable quadratic.
Okay, so that's the whole answer.
Yeah, I don't, in other words, you know that can't do any more with that, can't do any more with that, and if that's non-factorable, we can't do anything more with that.
Right.
All right.
All right. Number 11. We may have done that one in class.
11?
Yeah, we did.
11? Okay.
Yeah, we're on to 12.
Okay. Okay. Now, these are quadratics in disguise, basically. In other words, this is the same as this. Notice that a quadratic, the only definition of a quadratic is that this term is the square of that term. That's what makes a quadratic. Well, this is the square of that. So we can treat it like a quadratic. And the very first step, even if it was quadratic, in other words, even if it was this, what would our first step be?
Put it in parentheses.
No, always look for greatest common factor. That's why the top note on every problem here says GCF. Because that's always the first step.
It'd be 2.
Okay. Leaving behind what?
X to the 3rd.
Okay. Does that multiply back together again to give you the original term?
X to the 4th.
Okay. What else?
Minus
Divide 36x squared by 2.
15.
That's what we're doing. When we factor out a 2, we're dividing every term by 2. What's 36 divided by 2?
15x.
Well, 15 times 2 is what?
Oh, it's 30.
So you're not doing that check. When you give me an answer like that, it means you're not performing that little check.
Right.
That's the secret of arithmetic, is to always perform that check. Then you'll never make that mistake.
Right.
So try some numbers near 15.
It would be minus 6x.
2 times 6 is 12. We got to have half of 36. What's 36 divided by 2? It's 18. Because 2 times 18 is equal to 36.
Okay.
And what's the rest of it?
Plus 80.
Okay. Now, most likely we can treat that as a quadratic that's going to factor into x squared something and x squared something. Okay, notice that that produces the first term of x to the 4th. And this is just a regular quadratic. We're not talking difference of squares, cubes, or any of that. We're just factoring a quadratic. So we can apply that same rule. What are the signs?
Plus 8 minus 10.
What are the signs? Not the whole numbers. What are the signs?
Minus and positive.
Okay, minus times positive doesn't produce a positive.
They're both negative.
Okay. Only like signs can produce a positive. So they're either both negative or both positive, and then we look to the middle term. It's a negative, so they have to both be negative.
Right.
Now we can even say that we're looking for factors of 80 that add, because of that plus sign, to the number 18. And you've already figured it that it's 10 and 8. Okay?
Right.
10 and 8, multiply to 80, and add 10. And that's what we're looking for. Okay.
That's the whole name.
Well, and we still have a 2 there.
Oh, okay.
You can't drop that greatest common factor that you pull out. And that's difference of squares, but it's not difference of perfect squares. And that's difference of squares, but it's not difference of perfect squares. So I'm presuming we don't go any further here.
Okay.
As I said, you could call x squared minus 10 x minus square root of 10 times x plus square root of 10.
Right.
I don't think they probably want you to go that because that's an irrational number. They probably only want you to factor it down to rational numbers.
Right.
All right.
All right, number 14.
Must be the next one. Did your computer do weird things today?
Yeah, it does a lot of weird things.
No, my computer completely changed my desktop today.
Oh, that's not good.
No, I thought I had a virus for a while, and now I'm kind of convinced that Microsoft just changed their program.
Yeah, Microsoft isn't doing well right now.
Why? Did we do 13?
I did 13 with my teacher.
Okay. All right. So we want to do 14?
Right.
Again, this is a quadratic. Even though it looks like a quartic, we can treat it like a quadratic because this term is the square of that term. That's what allows us to treat it like a quadratic. Like any quadratic, we're going to factor out a greatest common factor. What is that?
That would be 2.
Okay. Leaving behind what?
That would be 5x squared.
No.
5x fourth.
Okay.
Plus 7x squared.
Notice what a nice check that is. When you multiply that times that and see that it's 14x squared, you know you've done it right. That's huge.
Right.
What's this term?
That would be 24.
Okay. Now, I'm presuming this is a quadratic that can be factored, so let's give it a shot. My first terms are going to be what?
That'd be x squared. And then x squared.
No, if I put x squared, those don't multiply to 5x to the fourth.
It'd be 4x. No.
How about 5x? 5x. Notice that x squared, 5x squared gives you 5x to the fourth.
Right.
What are the signs going to be?
Negative. No, one positive, one negative.
Okay. In this case, it matters. In other words, that is not the same as this.
Right.
So I have to allow for both of them. So the way I handle this is I write both of them like that.
Okay.
And the opposite on the other side.
Okay.
Okay. Now what are we looking for? Factors of what?
7.
No. Factors
No,
of the
factors
constant.
of 24.
Okay. So that's, and we can't say any more than that. We can't say factors of 24 that subtract to 7. We can't say factors of 24 that add to 7. Because the fact that we have different coefficients here than here changes that rule. You can't do that anymore. It becomes more of a trial and error.
Right.
So when you're doing trial and error, we know factors of 24 are 24 and 1, 8 and 3, 6 and 4, 12 and 2. Which two should we try, always, as a first trial?
Um.
The two closest ones.
Okay.
Always. Just always try the two closest ones. I have discovered that 90% of the problems in Colorado, the factors are the two closest ones.
Okay.
Okay? And we just randomly try it. I'm going to put 6 there and 4 there. Now we have to determine whether that produces the middle term that we're looking at. Does that produce 7x squared?
No.
Okay, and it doesn't even produce the correct number. It produces 26x squared. And if I put the 6 down here and the 4 over here, all I do is get the same number, different signs. So there's no point in trying that one. So let's put the 4 here and the 6 over there. Does that produce 7x squared?
No.
Okay. So 4 and 6 aren't the factors we're looking for. So let's try the next closest, 8 and 3.
Okay.
Well, 8 times 5 is 40. We're way out of it. So let's try the 8 over here and the 3 there. Now we're getting somewhere.
That'd be 15.
Okay, the middle term is 15x squared. And the outside terms are minus 8x squared. That's it.
All right.
That's our answer.
Okay.
Erase that other sign there. Erase all this stuff. And I still maintain that my method of trial and error is faster than your diamond method.
Right.
But I'm not completely sure about that because I don't ever use the diamond method. Mainly because I'm convinced it's slower. I think my method gets to the answer quicker. But I don't know for sure because I don't ever use the diamond method. I've got a little tutorial on how to use it. I
agree with you.
I could know if I had to use it, I could, but I don't think it's the fastest way, so it's not the method I teach. And, all right, can we do anything more with this? Is that anything? X squared plus 3.
No.
It's not the sum of perfect anything. How about this? That's not the difference of perfect anything. So we're done.
Okay.
$15. Is this a quadratic?
Yes.
Well, not yet it isn't.
Okay.
Because x to the 5th is not the square of x to the 3rd.
Right.
In other words, for it to be a quadratic, it doesn't have to be x squared, but this term, forget about the 50 for a moment, that term has to be the perfect square of that term for it to be a quadratic. So it's not that yet. Is there a greatest common factor here?
5.
Okay. No? What else? 5x.
5x.
Notice that if we take the x out, we'll be left with x to the 4th, x squared, and a number. That is a perfect quadratic. So we want to make sure we take the x out.
Right.
So 5x. What's left?
10x to the 4th plus 9x to the 2nd plus 10, or 5. No, plus 2, sorry.
It's all right. Okay, now we're looking at a quadratic. It's actually a quartic, but it behaves like a quadratic. meaning we can factor it probably. So, again, we got some choices. You rarely have choices in your first term. Usually it's x and x, or x squared and x squared. But 10 has multiple factors. So I'm going to suggest the same thing that I suggest everywhere else. Use the two that are closest together. Notice 5 and 2 are closer together than 10 and 1.
Right.
Okay. This may not work. We may have to come back and try 10 and 1. But let's start with 5 and 2. What are the signs?
Both positive.
Okay. How many factors are there for 2?
1.
Right, just 2 and 1.
Mm-hmm.
Well, if we put the 1 there and the 2 there, that does not produce 9x squared in the middle.
No.
But if we do the reverse, the 2 here and the 1 there, that does. We get 4,
right.
and we get 5. That gives us 9. Okay. And again, we can't do anything more with these. You can never do anything with the sum of perfect squares even. I mean, even if I had x squared plus 1, that's the sum of perfect squares, or x squared plus 4. That's the sum of perfect squares, but it doesn't factor. Only the difference, or rather, only the sum of perfect cubes factors.
Okay.
That's why there's only 3 things to memorize.
Right.
Okay, let's apply our first step that we always apply, which is to try to take a greatest common factor out.
Do 4.
For what? Don't forget the variable.
4x.
4x squared.
Squared.
Leaving what?
Would be x to the 4th minus minus 24.
About 12.
Yes. Oh, 12. Right.
12 what?
12x to 12x squared.
Okay.
Plus that'd be 70.
Okay. 4 goes into 3 times.
Oh.
So it's got to start with a 3 and then a 2. Okay. And now we do have something that is going to behave just like a quadratic.
Mm-hmm.
So we can factor that. Let's not drop that. Well, this is always going to be that. In other words, it's never going to be x cubed times x.
Right.
Okay, what are the signs?
Negative and positive.
Okay, you can't produce a positive by multiplying a negative and a positive together.
Oh, positive and positive.
Well, you can produce a positive that, but you wouldn't produce a middle term with a negative if you did that.
So,
okay, here's the rule. This means the signs have to be the same.
okay.
And they're whatever the sign of the middle term is. If the middle term's negative, then it's negative, negative. If the middle term's positive, it's positive, positive. It's that simple.
Okay.
Okay? Now, notice we have the same coefficient in front of the x squared term, and it's 1. So now we can go back and rely on our rules. What's the rule?
It has to be positive.
Well, we already decided it was negative, negative.
Right.
We need factors of 32.
Factors. Okay. And that
do
would
what?
be... that would be...
That add that plus sign.
8 and 4.
Okay. That add to 12. That's what we're looking for, is factors of 32 that add because of that to this number, 12.
Okay.
Okay? Now, that's not completed because notice there's one other thing we can do. That isn't perfect difference of perfect squares, but that is.
Mm-hmm.
So we can break this down further. We got 4x squared there. Can't do anything with that. But we can do something with this. What's A and what's B?
A is 4x.
Now we're talking about just this right here. That is A squared minus B squared. What is A?
Minus.
It's always the square root of that term. What is the square root of x squared?
1.
X.
X. Sorry.
What's the square root of 4?
2.
Okay, that's how you do it. In other words, you just take the square root of these. Once you realize that that is the difference of perfect squares, then to come up with A and B, just take the square root of that and the square root of that. Okay, so what's A minus B times A plus B?
A minus B. That'd be X minus 2. Times X plus 2.
And there's your final answer.
Okay.
Can't do anything with any of those further.
Okay.
That was 16, was it?
Yeah, now 17.
Okay.
I attempted it, but then didn't know what I was doing.
Well, we've got a cubic.
Mm-hmm.
And furthermore, we have a cubic that we cannot factor a greatest common factor out of.
Right.
Because we have a constant. Whenever you have a constant, well, actually, we might be able to factor a number out.
Mm-hmm.
First, I thought we could maybe factor a 3, but 3 doesn't divide into 20. So we can't factor any number out either.
Right.
So we have to deal with it as a cubic.
Okay.
Now, you've only been taught one method for handling cubics like this. It's called grouping.
Mm-hmm.
Okay? And it's only applicable when the ratio of that to that is the same as the ratio of that to that. In other words, is 12 over 20 equal to 9 over 15?
No.
Actually, it is.
No.
In other words, if I divide 3, or rather 4 into this, I get 3/5. And if I divide 3 into top and bottom, I get 3/5. So they're both equal to 3/5.
Okay.
So that ratio is the same. And that's all we need to group. Oh, hold on. That was a 12, right? Yeah. And we're going to group the first 2 terms and the second 2 terms. In other words, I'm going to group it like this. Okay? But notice that as soon as I go to put the parentheses around the second 2 terms, I have a potential problem.
Mm-hmm.
What goes there? Trying to group the last 2 terms.
X, or 9x.
What's the rest of it?
Minus 15.
Well, if I put a minus 15 there, and then I say remove those parentheses, what would you get?
9x minus 15.
You get 9x plus 15.
Oh, right.
So therefore the sign can't be correct on the 15.
So
Be
positive.
that. Notice now if I said remove the parentheses, you'd end up with what you started with, which is always the requirement. You have to end up with what you started with.
Okay.
The moment you change it, you've made a mistake. Okay? So now I've grouped it properly, and that's no mean feat because almost everybody misses the sign right there.
Mm-hmm.
And if you do, it won't group properly.
Mm-hmm.
You can't miss a sign, otherwise it screws everything up. Okay? Now, take the first set of parentheses and take out the greatest common factor.
4.
4x squared.
Okay.
Leaving behind what?
3x plus 5.
See, I can see right now that you're doing that check. You're multiplying that 5 by the 4x squared to make sure it's 20x squared.
Right.
That step makes all the difference in the world.
Mm-hmm.
What's the greatest common factor out of the expression on the right?
3.
Leaving.
So 3x plus 5.
Okay, now notice that we have a 3x plus 5 there, and we have a 3x plus 5 there.
Mm-hmm.
And it's not a typical factor problem, but you can actually factor out the 3x plus 5.
Right.
If I factor out that binomial, in other words, this is one of the few times that you ever factor out a binomial. Up until now, you've always factored out the greatest common factor has always been a single term.
Mm-hmm.
Okay, like 4x squared, that's a single term. A binomial means that something's being added or subtracted to it. But I can factor out that 3x plus 5 in parentheses. What's left behind?
3x minus 5.
No. You're going to divide that term by 3x plus 5. What's left?
4x squared.
There you go. And you're going to do the same thing over here. You're going to divide that term by 3x plus 5. What's left?
Minus 3.
There's your answer.
Oh.
You have factored a cubic. Now, it is possible that that could be difference of perfect squares and require more factoring. But 3 is not a perfect square, so we don't need to worry about it. 4x squared is a perfect square. That is the quantity 2x squared. So if this was any number that was a perfect square, we would have to factor this further. That could be a 1, that could be a 4, that could be a 9, that could be a 16, any of those numbers, and we would have to do more.
Right.
That's how you factor a cubic, by grouping.
Mm-hmm.
And that's the only kind they're going to give you. Notice that when we look at 18, it's also a cubic with a constant.
Mm-hmm.
That better factor by grouping, or we don't have any way to do it. There is another way, but it's so complicated you wouldn't believe it, and we don't even want to talk about it. But which means that this has to qualify as a grouping problem.
Right.
So let's see if those ratios are the same. What ratios are we concerned with?
25 over 20.
Well, it's actually 25 over minus 20.
Okay.
But that's okay, because the signs have to be proper. Is that the same as 30 over minus 24? Reduce each one.
That would be 5 over negative 4.
What's this one?
That would be 5, 5 over, okay.
In other words, I'm going to divide top and bottom by 6
Okay.
to get 5/4. So they are the same ratios. That means it qualifies for grouping. Okay, so what's my next step?
Take the greatest common factor out of it.
Let's put parentheses around what we're going to group together.
Okay.
So where do my parentheses go?
Around 25x to the third minus 20x squared.
Okay. And in this case, because there's a plus sign there, I can actually just go ahead and add the parentheses like that, and it's the same thing. It's only if there's a negative sign there that you need to worry about the sign on that term there. In other words, as long as it's a plus, I can put parentheses around it and it doesn't change anything. Now take the greatest common factor out of each.
5x squared.
Leaving?
Leaving 5 x minus 4.
And over here, what?
That would be 6. 6x. Right?
No, not 6x. There's no x on that 24. You can't take an x out.
Oh, right. That would be 5x.
Notice it's always going to be that same term. So you can save yourself the division by just knowing that it's got to be that. Otherwise, we wouldn't be able to do the problem. If it's not 5x minus 4, then this was a typo. Because that grouping is the only method you've learned, so if it doesn't group, you wouldn't put the problem on there. And if it groups, this term, this binomial term, is always the same as that binomial term. So what's the next step? Because they're the same?
Divide.
Factor out.
Factor.
What? What can I factor out of that term right there?
5x minus 4.
Yeah. And what's left behind? And when you factor it out, always put parentheses around it if it's a binomial.
Right.
Because it matters. You need parentheses.
Right.
What's left?
That would be x squared.
Hold
no,
on.
x.
Divide that term by 5x minus 4.
5x squared.
That's it. 5x squared. What else? Divide that term by 5x minus 4.
Plus 6.
That's how you do it.
Oh, okay.
That's the way you solve by grouping.
Okay.
And the only hard one ever is if this is a minus sign. If that's a plus sign, then it's a piece of cake. But if that's a minus sign, you have to be very, very careful when you group to make sure that you don't change the original function.
Right.
All right, Taryn. Well, hopefully that'll help.
That did. Thank you.
Yeah, okay. I will, let's see. What are we doing? Do we have a regular Monday still, or?
Yeah, Mondays still work.
Mondays at 5?
Yes.
Okay. Well, I'll just leave it there then.
All right, awesome.
Right.
Thank you so much.
Have a good weekend.
You too.
Happy Halloween, I guess.
You too. Bye.
All right, bye-bye.